I want to take you through a type of problem on Delta Math that involves this idea of U substitution, but kind of presents it in a little different way. Some ways easier, some ways just kind of different. So what they're going to do is they're going to give you a definite integral this time, meaning there are boundary numbers, your lower and upper boundary. And instead of writing it as something that is in like a normal function notation, they're actually going to write it in more of a generic notation. So I'm going to kind of mark this up a little bit so you can understand what I mean from the one on the screen. So they're going to write it where you have this f of this inner function. So this is going to be your u value, this piece in parentheses here. So you're going to actually start it very similar to the ones that we did earlier in this lesson. So you're going to have u be 1/4 x squared plus 5. You're going to take the derivative of that, find the du. So power out front, power 1 less, you get x over 2. You're going to look at what's actually in the problem. So in the problem, we have x. We don't have a divided by 2. So to get rid of the divided by 2, we're going to multiply both sides by 2. And that's going to become the adjustment of my integral. The way they're asking you to set it up, they actually don't want a final answer because truly they're way more concerned if you understand how this all gets set up. So they're checking for you to see what the adjustment is. So they put a blank in front of the integral. That's where you'll put your adjustment if there is one. And usually with these, they have an adjustment. Here's the other thing they're going to do. They're going to ask you to adjust your boundaries because you'll notice they're leaving the answer in U notation, meaning that it's still all U's instead of X's. So that means your boundaries have to match. Your boundaries also need to be U's. Well, these currently are X's. This is my lower X value. This is my upper X value. The way that we get that to be a U equivalent is we're going to take those X values and put it into my equation that tells me what U equals. So if I put my lower boundary is 4, so if I put 4 where the X is, and a lot of this is done with a calculator. So I have 1/4 times 16, that's 4. 4 plus 5 is 9. That means my lower boundary should actually be a 9 if we're in terms of U's. And then my upper boundary, when I put in 1/4 my 6 squared plus 5, I get a fourth of 36, which is 9. 9 plus 5 is 14. So you'll have to actually change your boundary. Sometimes this is referred to as a complete U substitution, meaning you're completely changing everything to U's. So what you're going to type in to Delta Math is you're going to type in what these new boundaries are. So 9, we say it was 9 and it was 14. And then we're going to put in our adjustment that we had when I did my U and my DU and submit your answer. See if they do it. They do it kind of similarly. I kind of like the way that we write it. They actually show the plugging in and putting in the boundaries is what you're looking for. Let me see if I can find one more that's similar to it. There's some other problems in this topic, but I like these specifically. Yeah, here's a good one. No, actually, I want one that just sets it up. All right, we'll do this one as my second one. So same idea here. My u is what is in parentheses. It's that inner function of f. So u is 1/3 x squared minus 5. The derivative is power out front, power is 1 less 2/3 x. We have the x piece. We don't want the 2/3, so we're going to multiply both sides by the reciprocal. That's going to be your adjustment. Oh, this one wants the final answer. You know what? I want to do one that doesn't want the final answer. I really want to do a setup only one. See if I can find one. Somewhere I should find one. Ah, perfect. And this one's actually a very simple one. So my u for this one is the inner function. So my u is 2x minus 4. Derivative of that is 2. I don't have a 2 there, so I'm going to divide both sides by 2. So my adjustment is 1/2. That's what's going to go in front of the integral. And then my a and b value, I started with 4 and 8. So now I'm going to put those into my u equation to figure out what they are now. So when I put 4 in, I get 2 times 4 minus 4 is 4. So that boundary actually didn't change. And when I put 8 in, I get 2 times 8, which is 16, minus 4 is 12. So that boundary did change. So you're going to go in and you're going to say that my boundaries are now 4 and 12, and my adjustment was 1/2, and submit your answer. So that's how we look at something where we're converting, we're doing a U-sub, but it's more about kind of putting it in a new form than actually doing a lot of actual final answer work. I think these are actually a little more like what you're going to see on an AP test.